All right, guys, now we're going to talk about dot structures. Dot structures are a way that we communicate. It's going to take you a lot of practice to figure this out. All right, we're going to start here. I will go over these problems in class, but I need you to try them. So this is how we do it. Number one, we count valence electrons. I'm going to go through this with methane, that's CH4. Carbon has 4 valence electrons. Look on the periodic table. Hydrogen only has 1, but there's 4 hydrogens, so each one brings 1. We could do this math pretty good. We get 8 valence electrons for methane. Pick the center atom. We're going to figure out which one's going to be in the middle. It's the atom that makes the most bonds. But here's a little hint. It is never, ever, ever hydrogen. Ever, ever. It's the one that makes the most bonds. Mr. Beck, how do I know which one makes the most bonds? This is the dot structure of carbon. You can see there's a single electron on 4 sides. That means carbon can make 4 bonds. You'll see where we're going with other atoms as we move along. So carbon goes in the middle. Boom. We're going to add single bonds to the other atoms right now. There are single bonds. If you looked at the previous video, you're going to see that single bonds are worth 2 electrons each. 2, 4, 6, 8. I've drawn 8 electrons. That means I have no more electrons to draw. This is the dot structure of methane. We're now going to move along, and we're going to do ammonia. I'm going to go a little quicker. Five from nitrogen. Each hydrogen brings 1 valence electron. That's 8. Nitrogen goes in the middle. All right, now if we look at nitrogen, I'll go through our situation first. I have made 3 bonds, just like what I did in step 3 right here. Each single bond is worth 2 electrons. I have 2 electrons left that I've got to figure out a place for. But if you remember the previous video, elements are looking to get 8 electrons. If I back up to methane around carbon, I have 2, 4, 6, 8 electrons around it. For hydrogen, I just have 2 around each because hydrogen only wants 2. If I go over here, each hydrogen already has its 2. Nitrogen, 2, 4, 6, only has 6 valence electrons right now. It needs 2 more. Conveniently, I have 2 more electrons there. 1, 2. This right here is called a lone pair, or an LP. Counts as 2 electrons. Nitrogen now has 2, 4, 6, 8 electrons. We're done. On to water. Water's got 8 electrons. I will let you do the counting. I think you can do it. O makes the most bonds. It's going to go in the middle. I got an H going down and an H going up. I used 4 electrons because each single bond is worth 2. Well, does oxygen adhere to the octet rule? Does it have 8 valence electrons? 2, 4. No, it does not. Where can we put these 4 electrons? 1, 2, 3, 4. There you go. 2, 4, 6, 8. Oxygen now has an octet. Everything's fantastic. CCl4. This one I'm going to go a little bit slower on because this one has some action going on. Carbon's got 4 valence electrons. Plus, each chlorine has 7, and there's 4 of them. If we do this math, we get 32 electrons. 7 times 4 is 28. 28 plus 4 is 32. I got to figure out what goes in the middle now. Well, what makes more bonds, carbon or chlorine? Well, this is what carbon looks like. And this is what chlorine looks like. All right? Carbon makes 4 bonds because it's got 4 of these single ones there. Chlorine only makes 1 bond because it's got 1 single one right there. The rest of these are already paired up. Can't make a bond with those that are already paired. So we're gonna jump back to our rules. We're gonna pick a center. It's gotta be carbon because it can make the most bonds. And we're gonna add single bonds to all of the chlorines. So in this case, I've used 8 electrons. I am down to 24 electrons because I've drawn 8 already. What we're gonna do now is we're gonna use lone pairs to get to 8 electrons around the outside ones. Chlorine here has 2 electrons, so I need 6 more to go around it. 2, 4, 6, 8. Now it's got 8. I just drew 6 dots, so I'm going to take 6 away from my total. This top one needs 6 more. This one here needs 6 more, and this one here needs 6 more. Because of that, I've just used up all of my electrons, and this is the dot structure for carbon tetrachloride. Now, we're going to get down here to CO2. This is where it gets really exciting. Carbon's got 4 valence electrons. Each oxygen has 6. So let's see if we can do that math in our head. 16 electrons. It's now that we're going to step into rule number 5. We're going to create some double bonds here. So, carbon can make 4 bonds. We've been going over that kind of a lot. Oxygen can only make 2. Which one's bigger, 4 or 2? Carbon goes in the middle because it can make 4 bonds. I am now going to add single bonds to the other atoms. If you're keeping track at home, I just used 4 electrons. I got 12 more. The way that we operate is we go from the outside in. We're going to complete the octet for the outside atoms. 1, 2, 3, 4, 5, 6. Why did we need 6? Because I have 2 electrons in this bond. 2, 4, 6, 8. We have 8 around oxygen. Over here, I got to do the same thing. I have just drawn 12 dots, people. I have no more dots. I can't draw anything else. The dots are gone. They're finished. We can't just put dots in willy-nilly. Okay? So now we have to start talking about double bonds. The octet rule is complete for oxygen and oxygen. This is wonderful. Is the octet rule complete for carbon? I don't think so. So what we're gonna do is we're gonna start taking electron pairs, like this pair right here, and we're gonna, well actually I'll go with the top one. We're gonna take this pair here, and we are gonna dump it in between the carbon and the oxygen. When we do that, we get a double bond there. 2, 4. A double bond has 4 electrons in it, so 4, 6, 8. Oxygen's got 8 electrons. This is wonderful. Does carbon have 8 electrons yet? No, it does not. So we're going to do a similar thing. But to be clear, I don't care which lone pair you erase. Doesn't matter. We'll get rid of this top one again, and we'll create a double bond. Carbon now has 2, 4, 6, 8 electrons around itself. It's very happy. This is the dot structure of CO2. And lastly, we're going to start to add some complexity to this. I have given you on your worksheet a couple that are really difficult. Do not Google the structure. Try to piece it together. Here, 1, 4, 4, 1. This gives us 10 electrons to work with. But both carbons can make 4 bonds. We'll just pick one that you want to be the middle. I'm going to pick the left-hand one because that's what I want. So carbon's here. There's carbon, carbon. This carbon here actually is bonded to the other H. Those of you that want to be doctors or nurses or go into scientific research, you're going to have to take organic chemistry. This is how people communicate. This is the mode. So we just use 6. Well, 2, 4, 6 electrons. I got 4 more that I got to do. Okay. I am going to pick this as my middle, which means from the outside in, remember, hydrogen only wants 2 electrons. It's got its 2, it's over. But this carbon here needs 4. 2, 4, 6, 8. Okay? But as you can see, this carbon on the left, it does not have 8 valence electrons. We got to figure out this situation. So I'm going to take these 2, get rid of them, create a double bond. Hopefully you're keeping track at home. 2, 4, 6. Does that carbon have 8 electrons? No. But can we fix that? Yeah. If we erase these 2 and create a triple bond in there, now everything has 8 valence electrons. Now acetylene gas is complete. This is how you draw. This is how we communicate. I have given you 12 problems on the worksheet that's in front of you. I want you to try to do them, all right? We'll talk about this on Wednesday. Please review the video if you need another go around.